Welcome to MATLAB optimization solutions. Today I am going to explain the estimating unknown parameter of solar cell using particle sum optimization. This project focuses on estimating the unknown parameter of solar cell model using PSO algorithm. It aims to accurately extract the PV parameter. PV parameters means IPs, I naught, RSS, RS, and N, that means diode ideality factor. It aims to accurately extract the key PV parameters such as photocurrent, diode saturation current, ideality factor, series resistance, and shunt resistance. Series resistance, shunt resistance, IPS photocurrent. A PSO technique inspired by the swarm intelligence efficiently searches for global solution with faster convergence and reliable performance. The model is validated through MATLAB simulation by comparing the estimated and experimental IV and PV curve. That is IV characteristics curve and another is PV characteristics curve. This work efficiently considered the RTC Franz solar cell where lower and upper parameter bounds are fixed for RTC Franz solar cell dataset. Lower and upper bounds, that means lower and upper. Here dimension 5. 0 on 0 1 0 100 0 0.5 on 2. Here 5 dimensions are used. The maximum number of iteration is set 50 to ensure faster simulation. However, increasing the iteration number can further enhance accuracy, improve convergence, and reduce estimation error. Estimation errors, that means RMSE value, root mean square error. These values, RMSE. The main objectives of this study are to minimize RMSE between experimental and estimated IV characteristics to accurately extract the photovoltaic model parameter. Photovoltaic model parameters, that means RSS, RS, I naught, IPS, N, that means diode ideality factor. That's why I am using dimension 5. To obtain IV and PV curves for figure 2, that is IV curve, and figure 3, that is PV curve. So obtaining IV and PV characteristics show a strong agreement with the experimental data. Here first is estimated data, second is experimental data. When this data are closely matched expected PV behavior, confirming the effectiveness of the proposed algorithm. Now I will run this file. After run, we'll see some figures. Just wait few seconds. First is convergence graph of particle sum optimization. Second is IV curve for PSO algorithm. Third is PV curve for particle sum optimization. Fourth is mean RMSE value for PSO algorithm. 5 is RMSE value for PSO algorithm, that is box plot. 6 is RMSE value for PSO algorithm, that's mean value. First, now I will try to match this manuscript. First is IV characteristics curve for single diode model. That is, for this figure, experimental data and PSO algorithm extraction achieves highly accurate, fitting with significantly reduces RMSE value. First is IV curve. Second is PV curve. That is PV curve. Here experimental data and PSO algorithm closely matches. Third is convergence graph for PSO algorithm. Here they used maximum iteration. I have only considered 50 iteration. Fourth is mean RMSE value for PSO algorithm after running 50 iteration. Figure fifth, the box plot for PSO algorithm. 6 is RMSE value for PSO algorithm. That is represent mean value. If anyone interested for these projects, please feel free to contact with me via WhatsApp or email. Thank you.